Hello students, sometimes it is difficult to establish a formula, but with the help of an activity, it is easy to establish a formula and even to verify the same formula. So students, today we are going to verify the area of a trapezium with the help of an activity. To do this activity, the material required are cardboard, colorful sheets, marker, ruler, glue, scissor and white sheet. Now, with the help of this rectangular sheet, we are going to draw a trapezium. As you can see, this is a cardboard. Now we can place this rectangular sheet anywhere in this cardboard, and with the help of a marker, we mark 4 points. Say suppose here, this is the first point, second point, third point and the fourth point. What is this? First, we join this. What figure is this? This is a trapezium. And you know what is trapezium? Trapezium is a special kind of a quadrilateral with a pair of opposite sides are parallel. Now, this A, B, C, D is a trapezium with AD and BC are parallel. Let us mark this AD as B units and BC as A units. And let us denote the height AE as H units. On measuring, we can also see that AD is 16 units, BC is 30 units and AE, that is the height, is 15 units. Now, with the help of colorful sheet and scissor, we make cutouts of this trapezium, and we have to make 2 identical cutouts of this trapezium A, B, C, D. As you can see, this, and they are both identical to each other. Now, with the help of these 2 cutouts, we are going to place these cutouts in such a manner, such that this forms this kind of a shape. And you can observe, what is this figure? It is a parallelogram. Let us name this parallelogram as P, Q, R and S. Let's name the meeting point of these 2 trapeziums as X and Y. Now you can see that this parallelogram is made up of 2 trapeziums. So what we can say? That twice the area of a trapezium is equal to area of this parallelogram. And what is area of a parallelogram? As we know, it is base into corresponding height. Now what is base? In this PQRS, as we can see in the parallelogram PQRS, the base is QR and QR is made up of QX plus XR, and we can see that QX is nothing but exactly similar to BC, which is A units. So let us write over here, which is A units, and XR is exactly same to AD, which is B units. So QR becomes QR plus XR, which is A plus B units. So we can write here as base. Base is QR into corresponding height. Now what is height in this? We can see since this parallelogram is made up of a trapezium and height of a trapezium is h units. So similarly the height of a parallelogram is h units. So this is h, and right now we have seen QR is a plus b into h. So area of a trapezium half into a plus b into h, or we can say half of sum of the length of parallel sides of a trapezium into the height. As we know, A and B, what is A and B? A is BC, which is one of the parallel side, and AD is the other parallel side. So we have verified that area of a trapezium is half the sum of the length of the parallel sides into height. Now let us calculate it mathematically. We can see that area of a trapezium is equal to half into a plus b into h. And right now we have seen that A is 30 units, B is 16 units and H is 15 units. So area becomes half into 30 plus 16 into 15, and we can see by mathematical manipulation it comes out to be 345 square units. Now let us see for the area of a parallelogram whether it is coming out to be twice the area of a trapezium. So as you can see, area of a parallelogram is base into corresponding height. Base is a plus b, which comes out to be 46, and height is 15, and we can see in this that it comes out to be 2 into 23 into 15, which is twice 23 into 15, which is twice of 345, and we can see that 345 is nothing but the area of a trapezium. So we can see that the area of a parallelogram is nothing but twice the area of a trapezium. This verifies that the area of a trapezium is half the sum of the length of the parallel sides into height. Thank you.